Good morning, boys. We are going to discuss some laws in solid as well as fluid mechanics based on design thinking aspect. So we need to understand what is the first one, design thinking. Empathy. What is the empathy to know about the law? Yeah, to know how the end user is using the law. Okay. So can we, what law you are going to say about?
Newton's first law.
Okay, without Newton's law, there is nothing. Okay, what is Newton's first law?
An object remains at the position unless it is acted upon any other external force.
Unless otherwise an external force is applied, a body or particle will be either at rest or in uniform motion. That is the first law of Newton. Okay, who is going to say about the Newton's second law?
So, force acting on a body is directly proportional to rate of change of linear momentum. Also, we can say that F is equal to ma. Force equal to mass into acceleration.
Force is directly proportional to acceleration. When the constant in the form of mass comes, we are saying that force is equal to mass into acceleration. That is the second law of Newton. What is the third law of Newton?
Every action has an equal and opposite reaction.
If there is an action, there will be an equal and opposite reaction. Is the Newton's third law. Those who don't know the law, you are in loss without Newton's laws. Okay. So what about yours? You are going to say about?
I'm saying about Hooke's law.
Hooke's law.
Nothing but the stress is directly proportional to the strain.
Under the elastic condition.
Elastic condition.
Under elastic condition, stress is always directly proportional to strain. We can insert a constant in the name of E, X modulus. So stress is equal to X modulus into strain. Okay. And another important law is Pascal's law, which is used in fluid mechanics. What is Pascal's law?
Basically, Pascal's law deals with the force and area relating with the pressure. So basically, if in a closed container, the fluid is at rest, then the pressure applied will be split equally on all the directions. So basically, that is Pascal's law, and its unit is Pascal. That is named after the scientist who is that.
Nice. Okay. The Pascal himself involves in the pressure. Yeah, he is never under pressure. So pressure at a point when the fluid is in rest will be equal in all the directions. The other important law is
Hydrostatic law.
hydrostatic
Which is
law.
similar to Pascal's law. But hydrostatic law states that when the pressure increases with the depth of the fluid, which is depends on the weight of the fluid. When the pressure increases, when the depth increases, the pressure also increases. And the formula is B equal to rho GH.
Yeah. If you are applying pressure on a fluid, when you are giving the pressure, when the depth is getting increased, the pressure will also get increased. That is known as hydrostatic law. Particularly, if the fluid is liquid, we are saying that as hydrostatic law. If it is air, if the fluid is air, we are saying that as aerostatic law. So we discuss about many important laws as like Newton's first law, Newton's second law, Newton's third law, Hooke's law, Pascal's law, hydrostatics law, and aerostatics law. Which law is important? Do you know? Can you fight with your law is important than his law? Like which law is important than which law?
Hydrostatic law is important than Pascal's law.
How come you say that?
So Pascal's law is under this only this theory.
Yes.
Yes, only theory.
Yeah, it is not practical.
Because he says when pressure acting on a fluid is split into.
Yeah, very good. According to him, Pascal's law applies when the fluid is at rest. But hydrostatic laws is when the fluid is in motion. For example, in the vessel with the 3 poles and the fluid is passing through, the fluid at the bottom will have the more pressure and the fluid in the middle will get the little less pressure and the top of the portion will get a very less pressure. Thank you so much.